Hey kids, it's Jurassic James, and on this Jurassic James Explains, we're looking at Elasmosaurus. Now, you may have heard of its cousin and possible ancestor, plesiosaurus. This is a different animal, same grouping though, they're still plesiosaurs, and I'll put a link in the description for my plesiosaur page and website. But what I want to point out with this guy is very simple. These are the ones that are actually from the late Cretaceous period, found in Kansas in 1867. So imagine, for example, the Civil War has just ended 2 years, and now we have paleontology resuming more in the field, and they find these guys in western Kansas. Now, what's so cool about it is the first one I have here, it's a company called Carnegie. Carnegie's no longer around, I don't believe, but it was this particular model is 1991, and the name of Elasmosaurus is reference to their hip bones. They have very flat hip bones, so it actually means thin bone lizard, Elasmosaurus. So these guys, I mean, that's why usually my dinosaur toys, they're standing up and you can see them broadside. They're all very flat because they're in the ocean. They're marine animals. They're trying to, swim around. So one thing to point out this guy is that overall it has all the basic parts. It has a long neck, which the animal's whole body length, the largest ones known, are estimated between 45, 47 feet long. I've heard 49 in one book, but 46 feet long. The neck alone is actually about 25 feet, or 26 feet. So the idea is that and that's like more than half the body. You're looking at this guy, it's about proportionately. In general, you have your four flippers, your short tail, your long neck. Once it was discovered, the bones were sent to Cope, a paleontologist in the 1800s. The Bone Wars. I've never really mentioned the Bone Wars on this channel, but on the Bone Wars, it's these two paleontologists who were having this huge, Autobot Decepticon fight. The point is, Cope put the head on the wrong end of the animal, famously, and Marsh, his rival, made a really big deal to point out how wrong he was. Anyway, so the idea is that if you look at a fish vertebra, it's concave. It goes in on both sides. But for vertebrate land animals or reptiles, for example, it's concave and convex on one side. So he got it mixed up apparently. Anyway, so moving forward, we have the same. That's a Carnegie, I think 1986. So basically, it's the repaint. These guys are the exact same figure. The difference is, if you look closely, if you get closer, the heads are slightly different. This guy has more of a blunter, shorter face, and this guy has a more elongated face. So that's actually a really good improvement if you ever see a real skull. I always tell you guys when I'm drawing prehistoric creatures, I always look at the skeleton, see where how the distance between the bones and the femur, the tibia, the shape of the skull. Other than a skull and paint, nothing really changed on these two models. Now, the next one I have here is a Toys R Us exclusive, back when that was a thing. And proportionally, I would think to the plesiosaur, because it has a shorter neck. But, it says Elasmosaurus in the stomach. Now, I did a whole video on the names of the stomachs being wrong. Fair enough. But, the skull is more the skull is like a toy dolphin. It's a pool toy, basically. I interpreted that as that. If I were a kid, I'd have it in a pool, right? Not these, they sink. This one would float. Anyway, so why the long neck? So in the early Jurassic period, where plesiosaurus is from Europe, it eats fish and squid. How do I know that? I'm glad you asked. Octopi have suckers on their hooks, suckers on their arms. Squid have hooks on some of their suckers. So we find those hooks in plesiosaur stomachs. We find belemnite shells in their stomachs, fish scales. So we know they're eating these animals, right? So the example I give on my tour is that if an ichthyosaur is there, and I always tell kids, if you're a squid, you're sitting and you're in the water, and an ichthyosaur comes near you, what do? And the kids always go, "Oh, I run away." I'm like, "You're a fish, post-Devonian. You had no legs. What would you do?" They go, I would swim away. Exactly. So it's large bodies there, comes at you. They're really fast. The plesiosaur is fast too, and I'll tell you why in a minute. But the idea is, if the body's back here and the head's right here, you can see the body moving. The head grabs you, kind of thing, right? This toy doesn't really show it, but the eyes, our plesiosaurs actually kind of look more upwards. So that implies they're coming up below and grabbing their prey like that too. That being said, if you are a Elasmosaurus and you late Cretaceous about 70 million years ago, and you have a 25-foot neck, and your body's way over there, the fish and squid don't see you coming, and you grab one of them. That's it, right? So we're seeing that nature's selecting for this longer neck. Now, some people will consider this convergent evolution to long sauropod dinosaurs. Because I remember when I was a kid, I didn't understand taxonomy, apparently. And I was like, long neck, Apatosaurus, Brachiosaurus, plesiosaurus, they must be related to each other. They're super not. Go to my website, I'll put a link below. They're not. But the idea here is it's parallel evolution. Like these animals, the long necks are getting longer necks to reach higher plants, to stand in one spot while they're grazing. The plesiosaurs are getting it. Now it's convergent and they're both feeding with their long necks, but what they're feeding on is very different. See, true convergent evolution is a ichthyosaur and a dolphin and a shark all having flippers and looking very similar because they're all in the ocean. Parallel evolution is very different than convergent evolution in that you have the same traits, but doesn't mean that you have for the same reason sometimes. So the idea is that these plesiosaurs and these sauropods are growing long necks, but to feed, just convergent, but they're feeding on different things, different reasons, different pressures. So it's kind of a weird thing to point out. And if you're in like college biology, it's a whole thing, it's a whole chapter, right? But the next one I'll point out is this little guy here, which is actually, ironically to me, like the best proportionate looking one. This is the, if you go to, usually Michael's Hobby Lobby, those kind of places, there is a little tubes from Safari, and there's one from Marine Reptiles. And this plesiosaur to me, even though it's tiny, is like the best example of a plesiosaur to me. The neck proportions, and the reason why I say this is that plesiosaurus has about 71 neck vertebrae. So if you were wondering, assuming you're a human and a dog and a giraffe and a mouse, we all have 7, right? They have 71. They literally have 10 times plus 1 vertebrae, we do. So there have been arguments, because when you see a plesiosaur in many paleo art, historically, they're usually with their necks out of the water, or with that classic like this monster, thing, like this, right? As we're gonna see my newer models, the necks are seen more horizontal. And the idea behind that is, they probably could, use enough to raise their head out of the water, but not really. Their lifestyle is in the water. Yes, they're air breathers. Good point. They have to come to the air to breathe, but you can come up to the water surface with your head and go like that and be done. You have to go all the way out like that. So, but again, lifestyle-wise, we're seeing more of this kind of like the necks going out, basically. Now, this one was a very special gift. Some friend of mine, the Geysers, went to Germany on a dig, or on a series of digs, and they bought this from a gift shop for me. And it's from Bullyland, which is a company I have Bullyland figures, but they're bigger in Europe, I think. And I remember I was so excited. Like, people were like, how can we make James happy? Like, find me some really rare new dinosaur toy or prehistoric creature toy. Anyway, so I like it because overall proportions, what I like about Plesiosaurus, even though it was found in 1867, there's not a whole lot of change. Like with Stegosaurus, you saw my Stegosaurus video probably. It's just this one, Triceratops, this one. There's a lot of changes in the figures, different interpretations. Plesiosaurs are pretty consistent. People aren't really like, they have real features. They're pretty like, this is what they are. We got it, Is there still a lot to learn from the animal to interpret yes, of course. But in general, if you're looking at the figures, you're not seeing a whole lot of difference other than like engineering versus, engineering, right? The last one I have here is, who is this again? This is Safari. And this one again is one of the ones that has like that classic look. Pterosaurs like Quetzalcoatlus have very few vertebrae, so their necks are more like cranes in some way. Like, I'm sorry, not the bird, the machine. Less articulation in the neck. Plesiosaurs having more vertebrae means they can move slower. Plesiosaurs having more vertebrae mean they can probably move their necks more. So this figure also is pretty good, very nice. So the idea is that you're seeing that. Now, one thing to point out with the flippers, if you've ever seen a penguin, penguins have football-shaped bodies, and they have 2 flippers, and they can maneuver really well. What you're seeing here is the same system times 2, like literally. So having 4 flippers, these guys can maneuver even faster because they're eating really fast food, like fish and squid. Their teeth jut forward, basically. No chewing, they're just swallow, And people go, well, can they eat bigger animals? Well, it's not like a snake that'll unhinge its jaw and all that. These are not like that. They're small mouth, small diet, small prey thing, right? But with that being said, let's look at a couple more things. So first and foremost, I want to point out it's family. So it's on the site. There's a Plesiosaurus page. And Plesiosaurus is the big name. Within that, we have 2 branches. The Plesiosaurids, these little guys here, not little, the long neck guys. And then the short neck ones are called plesiosaurs. I think I did a video on Chronosaurus. So here's Chronosaurus, another one. There are other plesiosaurs too with long necks, and they're labeled on my site, but it depends on where they're from and when they're from. So the plesiosaur lineage again start in the late Triassic, and they survive until Cretaceous extinction. That's a long time. So even though Elasmosaurus is most well known, found in North America, because let me explain. An ocean, if you don't remember, cut North America in half about 80 million years ago. It was a giant ocean, and so if you were in Kansas or Oklahoma or Utah, you would see a beachfront property basically. And in Kansas, we find all these marine animals because it's this ocean there. As it drained out, we see the continent we have today, right? So a lot of paleontology has been done there. So we see a lot about Elasmosaurus, but there's some found in California. The plesiosaurs found all over the world. Europe did it first because paleontology started in Europe, but they're everywhere else too. And they say, well, how do you tell them apart? Well, one, the skull shape, the length of the neck, number of vertebrae, all these little details are there, and also the different locations and different times, different rock layers. But also the environment in the Kansas Sea. I think Nigel Marvin said it best. He's a zoologist, I believe, and he does like these documentaries with time travel and creatures. And he said it's called the Great Western Interior Seaway, and he said that is if a devil had an aquarium or Satan's aquarium, that will be it, because we have these giant plesiosaurs, we have mosasaurs in there. The ichthyosaurs, I think, they died around 90 million years ago, so I'm not sure how much ichthyosaurs you was seen there. There is a short-necked plesiosaur called Deinonychus, and then there are sharks swimming. So if you have the prehistoric shark tooth from Safari, there you go. We have ammonites and other squid swimming around the environment, and we have fish. So this is this really interesting sea. So I always tell people in Houston, in the museum there, that if we were standing in Houston, what we now call Houston, in the late Cretaceous period, 75 million years ago, we will be standing on the bottom of a reef, shallow limestone bed. We'll be standing on limestone or slime muds, and there'll be coral around us, and above our heads we see giant turtles and plesiosaurs and mosasaurs swimming above our heads, and then we drown because it was pretty deep. So that's the world it's from, and I believe, last I checked, they supposedly have found plesiosaurus remains of this genus, Elasmosaurus genus, in Japan. So I mean, again, ocean animals. We know from Chronosaurus found in Australia and I think Peru or Colombia, that region. So the idea is that they're ocean animals. They can span greater distances. Whereas a Tyrannosaurus rex is found like from Texas to Alberta. That's this range. These guys can be found everywhere. But again, they're different species, have different features, and so on and so forth. But that's a whole other lecture. That being said, I will call this to a close. I will give you a heads up. Our next 3 talks will be Megaceras, a giant antlered deer, Augustinia, a armored sauropod, and Postosuchus. After that, I will have finished the 1-year commitment to dinosaur videos. If you like what I'm doing, share, tell your friends. At some point, those bubbles and boxes will show up. And like I said, share and tell people you like it. Give me comments, let me know what you're thinking. That being said, I will see you guys later. Thank you very much.